Hello dear students, welcome to a new algebra session. Today we'll be talking about intervals. Let's now start and see what are the intervals and what are they talking about. Let's remember this together. If we say that set x equals, where x belongs to the integers and x is less than 3, this means that x can be 3, 2, 1, 0, -1, and so on. How can we represent this on a number line? We go and plot on the 3, 2, 1, 0, and we keep going to the left. Now we'll be talking about closed intervals. The set x, where x belongs to R, -3 is less than or equal to x, and x is less than or equal to 2. As you can see here, that it says less than or equal. So the -3 is included, and the 2 is also included. So here, the values of x, they start at the -3, and they keep going to the right until they reach the 2. The -3 is an accepted number, and the 2 is also an accepted number because it says less than or equal and greater than or equal. So the accepted numbers are what? Are all the numbers from -3 until 2. How can we write this as an interval? We write it this way. This closed bracket, -3 until 2, and then another closed bracket. If you want to say it, you say it from -3 closed until 2 closed. How can we represent this on a number line? By making two closed circles, two shaded circles, one above the -3 and the other one above the 2, and we connect between them. So x can be any value starting from the -3 until the 2. -3 is included and the 2 is also included. Semi-closed or semi-opened intervals. If we say that x belongs to R, where x is greater than -3 and x is less than or equal to 2. Here, as you can see, x is greater than -3. We did not say x is greater than or equal -3. We said only x is greater than -3, but we said that x is less than or equal to 2. So x starts from the -3, but the -3 is not included until it reaches the 2, but the 2 is included. So if I write the intervals, they will be from -3 until 2, but the -3, the bracket is reversed. That's why we call it an opened bracket. Okay, so the values of x here start after the -3 until it reaches the 2. How can we represent this on a number line? You will find that the circle above the -3 is a white circle, is a not shaded circle. This means that it's opened, where the circle above the 2 is a closed circle. This means that it is closed. So remember in here, the -3 does not belong to this interval. Unlimited intervals. If we say that x belongs to R, where x is less than or equal to 1. Why is it unlimited? Because x is any number less than or equal to 1. So it starts from the -infinity until it reaches the 1, and here we have or equal to, then the 1 will be closed. And remember, the -infinity and the positive infinity are always opened. Infinities are always opened. So this one is from -infinity until 1 closed. How can we represent this on a number line? 1 closed, we make a circle. This circle is a closed circle, is a shaded circle above the 1, and it keeps moving to the left, going towards the -infinity. Note that the 2 does not belong to this interval because the 2 is at the right-hand side of the 1, and we said it's less than or equal to 1. -5, belongs to this interval because it's going left, passing through the negative 5. Let's move to the exercise and see the first one. The question is asking us to choose the correct answer. Question 1. R is equal to what? First choice, R positive intersects R negative. R positive union R negative. From negative infinity to positive infinity, Q intersects Q dash. Yes, your answer is correct. The R is only numbers, so it's from negative infinity until the positive infinity. Question 2, R positive is what? R positive is the set of all positive numbers, right? So, positive numbers, they start from where? From the 1? No, not from the 1, because there is a half. There is a quarter. From the 0? No, because the 0 is not positive. So, how can I start the positive numbers? It's right after the 0, but the 0 is not included, right? So here, we're going to say that it's from 0 opened up until the positive infinity or the infinity. So the interval will be from 0 opened until the infinity, which is choice A. Question 3, the R minus or the R negative, which is the set of negative numbers. Set of negative numbers, they start from the 0, but the 0 is not negative. So it's from 0 opened until the negative infinity. But when we write the interval, we write it from left to right. So it's from the negative infinity opened until the 0 opened, which is choice B. Question 4. The set of non-negative real numbers is what? Okay, the set of non-negative real numbers, does it include 0? Yes, because 0 is not negative, right? So it's 0 or positive. So 0 and above. So 0 closed until positive infinity. So here it is choice C. The set of non-positive real numbers, the non-positive real numbers are 0 and negatives, right? So it's from 0 closed going left until the negative infinity. So the interval is from negative infinity opened until the 0 closed. So here the choice is choice D. Another type of question in example 2 is to complete. In question 1, in your opinion, what is the relation between 3 and this interval? Yes, excellent. The 3 belongs to this interval because this interval includes 3 because the 3 is what? Because the 3 is closed. Question 2, negative 2, does it belong here? No, here it's open, so the negative 2 is not included. So negative 2 does not belong to this interval. In question 3, from negative 1 closed up until the 4 opened, is the 0 in this interval? Yes, the 0 belongs to this interval. The absolute value of negative 3, the absolute value of negative 3 is 3. Is the 3 from the 2 closed until the infinity? Yes, so this one, it belongs to this interval. Square root of 9 is 3. Does the 3 belong to this interval? Yes. How? Because this interval starts from negative 3 opened going all the way up until the positive infinity. So the 3 for sure is there from the negative 3 until the infinity. The cubic root of negative 1 is negative 1, and you're going to check, is the negative 1 there from negative infinity until 1? Yes, it also belongs to this interval. Let's now move on to another type of question that is giving us the number line and is asking us to write the interval that is representing the number line. Let's go and see the first one. Question A. You're going to say that it's from 0 until 3. Yes. But now, is this circle a shaded circle? Yes, we call it closed, so it's until 3 closed, and this one is also another shaded circle, so it's from 0 closed until 3 closed. Here is from -3 until -1. But the -1, it has an open circle. Open circle means what? Means that the -1 is opened, and here the 3 is closed because it has a shaded circle, where here in the -1 the circle was not shaded. Question C is from -4 until 1. The -4 is open because the circle is not shaded, where the 1 is closed because the circle is shaded. Question D is from 0 to 6, where the 0 is opened and the 6 is also opened. Let's now move on to the evaluation part. In question number 1, the question wants us to write each of the following in an interval form, then represent it on a number line. So let's do the first question. It's from -4 until the 2. And you can see here, the 2 has or equal sign, so it's closed. And then this one is open because it's just less than, not less than or equal. And how to represent it on a number line. Here's the number line. Here's the -4. And this one is the 2. The 2 is closed. The 4 is opened, and we connect between them. And this one, y is greater than or equal to -5. So it's from -5 all the way until infinity. Infinities are always opened, and the -5 is closed. How can we represent this on a number line? It's from -5 closed all the way until infinity. Question 2, the question is asking us to represent each of the following on a number line and express it by the description method. So, in this question 2, here's the number line from -3, and here's the 0. The 0 is opened, the -3 is opened, and we connect between them. How can we write it in the description method? Here is x, where x belongs to R, and here the -3 is less than, x is less than the 0. Question 2, the number line, here's 2 closed, and it's going all the way towards the -infinity. How can we describe this? We can make it, this is x, where x belongs to R, where x is less than or equal to 2. Dear students, by answering this question, we came to the end of our session today. Thank you very much, and best of luck.